Hi, we'll be looking at the concept of fat, oil, soap, and detergent. Well, this concept is derived from biochemistry. And then in biochemistry, you are going to study biological molecules, or what we call the biomolecules. Meanwhile, we are deriving this course from biochemistry into your high school, whether grade 1 or 2, and secondary schools. Now, the first thing is fat and oil. What's fat and oil? That's the first thing. To know what fat and oil is, you must be able to know that fat and oil is a derivative. When I mean derivative, is a material gotten from another source. Okay? So fat and oil is derived from the source known as lipids. Known as what now?
Lipids.
Lipids. These lipids are biological molecules. If you have heard about the word biological molecules before, you have heard about carbohydrates. So, carbohydrates are biological molecules. We have heard about the word protein. So, protein are biological molecules. We have heard about the word now lipids. So that's where we get the word from, lipids. So, and also we have nucleic acid. Alright, now if you're going to study biochemistry, these are the 4 major biological molecules you will be studying in school. Meanwhile, in today's concept, we're just looking at fat and oil, soap, and detergent. And we find out that fat and oil is a derivative from lipids, and that lipids is one of the biological molecules or compounds that is studied in biochemistry. So the next thing to look at is what are the features or the characteristics of the biological molecules, active biological molecules we call lipids. Take note of this. Lipids, one, is insoluble in water. That's the first thing. Lipids is insoluble in water. Number 2, if you're writing. Number 2, lipids is soluble in organic solvents. Lipids is insoluble in water, and then it is soluble in organic solvents. Then major one is that lipids is a biological molecule. It's an active biological molecule. Alright, and you understand that fat and oil is a derivative of lipids. And then you now know the features of lipids. I've told you, biological molecule, insoluble in water, but soluble in organic solvents. Alright, having known that, the next thing to go to is what actually are the examples of lipids. Well, we know that fat and oil is an example of lipids, but we want to expand our view, we want to understand more. What are the examples of lipids? Well, there are so much, lot of those examples, but I'll give you some of those. The ones that you are familiar with. So we're looking at vitamin. So, vitamins are examples of lipids. You know there are 2 types of vitamins. We have fat-soluble vitamins and we have water-soluble vitamins. Why can't we call water-soluble vitamins, fat-soluble vitamins, water-insoluble vitamins? Why we can't use that term is that it is technically incorrect to say water-insoluble vitamin, but it's actually what we mean by fat-soluble vitamin. It means those vitamins cannot dissolve in water. So, part of the lipids are vitamins and essentially fat-soluble vitamins. These fat-soluble vitamins are vitamin A, vitamin D, vitamin E, and vitamin K. Alright, vitamin A, vitamin D, vitamin E, vitamin K. Well, you can use, if you're Yoruba guy, Ade K. Ade K. So, Adeki, not Adeleke, Adeki. Alright, if you're about that. Now, meanwhile, the A is the retinol. The D is the calciferol. The E is the tetoferol. Then the K we have the K1, the K2,
and K4.
and the K3. The K1 is known as the phylloquinol. The K2 is known as menaquinol. The K3 is known as menadiol. So, alright, all these guys are the fats soluble vitamins, or you can use a second or maybe a layman language, water insoluble vitamins. Are you still there?
Yes.
Alright, now meanwhile, we can see the function of retinol. Retinol is for sight, that's for your eyes. Help to develop the senses of the eyes for proper view or broader photoelectric view. Now, we have calciferol, which is found for the bone strength, helps for your bones. Alright? So we have tetoferol, one of the vitamins that is found in egg. So you have to eat a lot of egg or some other sources like liver. So you find that source there. So we have K1, K2, K3 is depend on synthesis. Now this guy depends on synthesis on the food that we take. But that's not the concept for today. Let's come back to another example of lipids. Another example of lipids we have is hormones. Now, for you to talk about hormones as part of your lipids, it means that those hormones, they are insoluble to water, but they are fat soluble. They dissolve in organic substance. Alright, now those hormones are the steroids. Steroids. You have heard me talk about hormones in most of our classes. Now, those steroids is estrogen. Estrogen is a steroid, or is an example of steroid because it's part of an insoluble hormone that's also hormone that is not soluble in water, or a fat soluble hormone. So we have another one, progesterone. So we have another one like the testosterone. Okay? And we have the most comfortable one, which is cholesterol. Cholesterol, there also is a type of steroid, not an hormone now. It's a type of what? Steroid. Are you there? So now what estrogen, progesterone, testosterone, these guys are hormones. And then these hormones are kind of a steroid. Alright, now you should be careful about, or you should be careful with steroids, because steroids, or some steroids, are found in drugs. You need to be careful of steroids drugs. Now, those steroids drugs, you'll hear about some drugs known as C or nolone and hydrocortisone. Alright, now why I brought up these steroid drugs is because of the effects these drugs can cause. Now, if you look at triamcinolone and hydrocortisone, the only difference between these things is that they do the same function. If you go to the hospital, if without prescription, you are about to be injected with triamcinolone, you should ask a question. Because this particular steroid injection can lead to so much side effects. For instance, it's used for treating skin problems, skin inflammatory problems, or infection. But meanwhile, when you use the cream or the injection of this thing in an overdose, it can cause some reactions in your body. Alright? But the one of hydrocortisone You can get this one over the counter. Over the counter, I mean is that you can get that without prescriptions. You can inject it, nothing will happen to you. Because it's a diluted form of trimethylene. Are you following now? But for this trimethylene, it's only given under prescription, doctor's prescription. So, next time you go to the market to get drugs, steroid drugs, ask questions whether it has high potency or it has a low potency. Because this guy has medium to high potency. This guy has medium to low to medium potency. You understand what I'm trying to say?
Yes, sir.
Now, we go to one more example of steroid. And that example is what we have on the board already. But not steroid now, lipids. Okay? So that's the example known as fats and oil. Well, is fat and oil vitamins, hormones, steroid-like hormones, only the lipids? No. We have other lipids like the waxes. We have other lipids like the lipoprotein. We have other lipids like the phospholipids. We have other lipids like sphingolipids. But those are classes we'll be studying when we do lipids as a topic. Are you still there? So let's come back to what we have there, fat and oil. And I've got you to lipids, and you have seen what lipids is all about. Fat and oil again is a derivatives gotten from where? Lipids. And lipids is a biological active compound, organic compound that is insoluble in water, but it is soluble in organic substances or solvents. Are you still there now? Now, for the fat and oil, before we go to the study, I want you to know that fat and oil has been used as a source of food for all human. Foods that contain fat and oil, when you take those food, they can help to supply energy and protein to your body. Or protein and fat. Then the protein and fat is converted to energy. Meanwhile, the fat and oil, as I've told you, can be used for medicine. You can use to or synthesize drugs. Let me take you. We're in the class. Have you seen some syrups? Some drugs known as syrups. Have you seen it before?
Yes.
That is like liquid, but not that liquid. Alright. Now you ask yourself a question: what makes that syrups? What makes it sweetening? Some of them taste sweet, and some of them look semi-liquid. Are you following now? It's gelatinous, semi-liquid. Now, the particular fat or the particular fat substance that is used for it is called glycerin. Alright? Glycerin is used to thicken those liquids so it will not be too fluid and to add sweetness to those liquids. Now, meanwhile, other fat drugs like heparin. Heparin, if you have a person suffering from thrombosis, blood clots, thrombosis, when the person takes heparin, it will help to resolve or dissolve the blood clots. Alright, let's leave those things. Let's go now to fat and oil. How can we make fat and oil? I believe I've helped you. Alright, fat and oil. Actually, fat and oil is also known as alkaloids. It's known as what? Alkaloids. Alkaloids is an organic compound that is formed from the addition of alkaloid plus alkanol. And it will give you what? Alkaloids. And water. Alright? So before we deal with these, fat and oil, I want to just pick one example and go on the board with alkanoic acid, alkanol, that will give us alkaloids and water. This is an aspect of organic chemistry. Okay? Now, If you look at, let's pick one alkanoic acid, carbon atom 3. Okay? Let's say we have CH3, CH2, and then COH. All right. Now look at this. 1, 2, 3. This carbon atom is known as propanoic acid. What's it called?
Propanoic acid.
Propanoic acid. Now let's combine it with ethanol. C2H5OH. All right. This one is called ethanol. If you react these guys together, they are going to form alkanoates. They are going to form what? Alkanoates. All right. Now the first thing to do, we have CH3, CH2, COO, then this guy there, C2H5 plus H2O. The name of this